What you're about to see is a series of short outtakes from the HGMA certification film for the Wilswing HP170. The purpose of the HGMA certification film is to document compliance with the various sections of the certification standards. These standards require that the glider be capable of all maneuvers incident to normal flying without requiring special skills on the part of the pilot. Launching, stalls, turns and slips, gliding flight, and landings are among the required normal maneuvers. This section of footage on general flight maneuvers demonstrates the glider's inherent tendency to coordinate itself in turns and to maintain a reasonable degree of coordination in the event that the pilot does not make all the proper control inputs. Control authority must be shown in both roll and pitch. In roll, a 45-degree coordinated circling turn must be able to be reversed within 4 seconds at the minimum recommended wing loading. In this film, roll reversals on the HP are shown in 1.8 to 2 seconds. In addition, it must be shown that the glider either is incapable of spinning or that it will recover readily from a spin. In this sequence, spins are attempted by putting the glider into a turn and then pushing out all the way on the control bar while moving to the high side of the control bar, attempting to induce a stall of the inside wing and the resulting spin. The glider can be spun, but it is strongly resistant to being spun, and upon relaxing of the control pressures, the glider will exit the spin without entering an unusual attitude or exceeding the placarded speed limitations of the glider. In addition, the glider must be flown into a dive of at least 75 degrees, and the film must show the angle of the dive and the recovery to normal flight. The final flight maneuver to be demonstrated is the landing. Onboard film footage must show longitudinal control, a maximum dive speed of at least 35 miles an hour, and must show that the glider has an inherent trim speed and will always seek and return to that speed from any speed within the normal operating speed range. The camera here is mounted on the control bar down tube, looking almost straight down at an airspeed indicator and a mirror which reflects a view across the control bar, showing the position of the pilot's hands on the bar. The initial acceleration during pull-in was to 60 miles an hour. Then the glider goes through a series of porpoises in pitch even while the pilot holds a constant position, as the stability and dampening gradually bring the glider back to its normal, maintainable top speed, which in the case of the HP is about 55 miles per hour. When the pilot releases his hands from the bar, the glider returns to its normal trim speed of 22 miles per hour. The pilot repeats the maneuver from a number of different speeds within the speed range, at this point taking the glider up to 42 miles an hour, and then relaxing and allowing the glider to return to its trim speed. The pilot's open palms against the bar demonstrate that the glider is always seeking to return to its normal trim speed, and that the pilot always experiences positive bar pressure throughout the maneuver. This section of the standards requires that return to trim be demonstrated from 3 speeds above trim, including the maximum steady state dive speed of the glider, and also from 1 speed below trim. The pilot's open palms behind the control bar as the glider's airspeed drops to an indicated 18 miles per hour indicate positive tendency to return to trim from speeds below trim. This section of footage shows a series of very mild wingovers and shows how the speeds attained in such maneuvers can exceed the normal steady state dive speed of the glider. The indicated airspeed in that last maneuver reached 68 miles an hour, and the bank angle of the wingover was probably not in excess of 90 degrees. On the test vehicle, the pitching moment coefficient is measured at speeds of 20 miles per hour, 30 miles per hour, and 40 miles per hour over a wide range of angles of attack. A graph of the moment coefficient is plotted, and the area under this curve must be sufficient to indicate that the glider will offer a reasonable degree of resistance to tumbling. The scale with the glider currently at the zero lift angle of attack is now reading about 25 pounds. And this is at 20 miles per hour. The forces climb rapidly as the glider goes to a negative angle of attack and the bridles kick in, with the forces reaching over 50 miles an hour at negative 30 degrees. Three load tests are required on the vehicle. At the stall angle of attack, the glider must sustain a speed of at least 65 miles an hour for at least 3 seconds. Tufts are used to indicate that the airflow in the root section of the glider is separated and that the glider is set at the proper angle of attack. On this film, the HP reaches 72 miles per hour without damage or permanent deformation. That's currently 60 miles per hour indicated, 65, 70, and 72 miles per hour. Film footage taken after the positive load test shows that there was no permanent deformation or damage to the glider during the test. In the negative 30-degree test, the required speed is 46 miles per hour. This is also the recommended never-to-exceed speed for which the glider is placarded. The HP reaches 50 miles per hour in this test. That's 40 miles per hour, 45 miles per hour, That's 50 miles per hour. Note the extreme distortion of the leading edges. Once again, the film documentation shows that there was no structural damage or permanent deformation to the glider during the test. In the negative 150-degree test, designed to measure the glider's ability to hold together during a tumble, the glider must hold together for 3 seconds at least 32 miles per hour. In this film, the HP reaches 38 miles per hour in the negative 150 test. That's an indicated 25 miles per hour. That's 30 miles per hour. That's 35, 38 miles per hour. After passing all of these tests, it is hoped that the glider has shown a sufficient level of airworthiness that when flown by a conservative pilot within the placarded limitations, it should provide a reasonable degree of safety to the pilot.